Multiplying and dividing radicals. In order to multiply and divide radicals, they must have the same index. For instance, the nth root of x times the nth root of y, multiplying two radicals with the same index, you can basically combine the two radicals into one, giving you the nth root of x times y. Or in other words, you can simply multiply the two radicands together. Likewise, dividing radicals, the nth root of x divided by the nth root of y, dividing two radicals with the same index, you can combine the two radicals into one, or simply divide their radicands together. So the steps for multiplying and dividing radicals, you want to begin to see if you can simplify anything. Simplify the radicand, simplify the radical if possible. And then multiply and divide the radicands that have the same index. And then finally, check to see if you can simplify again your final answer. So example 1, notice still no equal sign. We're not solving anything, we're just simplifying. No parentheses, no exponent, so multiplication is obviously the only operation. Square root of 3 times the square root of 6. Multiplying two radicals with the same index means we can go ahead and multiply their radicands together. Square root of 3 times 6, which is of course the square root of 18. Square root of 3, square root of 6 could not have been simplified at the beginning, but now that we multiply them together, we have a new radical which can be simplified, which we know how to simplify radicals at this point, so it simplifies to 3 times the square root of 2. Example 2. Same type of problem, except working with variables, multiplying two radicals. So right now the radical can be simplified. When you're asked to multiply radicals, of course, look at their index, and they're the same, so that means you can multiply the two together, which gives you x squared times x to the 4th. Product rule of exponents, you're multiplying two powers together with like exponents, so that means you simply add their exponents together, giving us the 5th root of x to the 6th. But now that we have a new radical, we see that we can simplify it now. It simplifies the x times the 5th root of x. Example 3. A little bit larger problem, but if we rely on the order of operations, it'll still walk us right through it. Since there's no equal sign, we're just simplifying. Step number 1, simplify each radical, or excuse me, simplify each set of parentheses. The first set of parentheses, of course, we can't do any addition or subtraction. We know how to add or subtract radicals. They have to be like radicals, and they're not, but we notice that square root of 12 can be simplified. Square root of 12, break it up into 4 times 3. The square root of 4 is 2, so you bring it out in front with that 5. That gives us 10 times the square root of 3. You cannot simplify the square root of 5, so we just carry it through. The next set of parentheses, that first radical, once again, can be simplified a little bit. Square root of 20, break it up into 4 times 5. The square root of 4 is 2. Bring it out in front with that 3. 2 times 3 is 6, leaving us 6 times the square root of 5 plus 2 times the square root of 21. So no exponents to work in the next step in the order of operations, so of course that brings us to multiplication division. No division, but we're asked to multiply these two sets of parentheses together, and each set of parentheses is a binomial, two terms. So in other words, in order to multiply two binomials, we know we need the FOIL. So begin with multiplying the first terms, 10 square root of 3 times 6 square root of 5. Multiplying two radicals, they have to have the same index, and of course they do. So begin by multiplying the coefficients. 10 and 6 gives us 60 times the square root of 15. The outer terms, 20 square root of 63. The inner terms, 6 square root of 25. And the last terms, 2 square root of 105. The next step, of course, addition or subtraction. Well, right now we don't have any like radicals, but we know in order to add or subtract radicals, we have to check to see if we can simplify again. Well, that first term, square root of 15, cannot be simplified. The second term, square root of 63, can. 9 times 7, so the square root of 9 is 3. Bring it out in front with that 20. Gives us 60 square root of 7. The third term, square root of 25, is a perfect square, so 6 times 5 is just 30. And the last term cannot be simplified, so it remains 2 square root of 105. At this point, we simplified each radical, and we still do not have any like radicals, so no addition or subtraction to work. In other words, we're done. It's completely simplified at this point. Example 4. Look and see what's going on. The square root of 100 over 5. Of course, we always want to simplify as much as possible first, so 100 over 5 reduces to just 20, leaving us the square root of 20 that we can easily simplify to square root of 5. And example 5, now we have two individual radicals being divided. So in order to divide radicals, they have to have the same index, and of course they do. So we combine or simplify like radicals, beginning with the 16 and 2. 16 over 2, of course, just simplifies the 8. Now the radicals, the cube root of x squared over x, of course, simplifies to just the cube root of x, so 8 cube root of x. So multiplying and dividing radicals. The next step, working with these radicals, is called rationalizing the denominator. From this point forward, we want to make sure we never leave a radical in the denominator of a fraction. It's not considered simplified. So if we have a radical in the denominator, we need to get rid of it. The process for getting rid of radicals in the denominator is called rationalizing the denominator. And there's going to be two methods for doing that, depending on how many terms are in the denominator. The first method for rationalizing the denominator is if we only have one term in the denominator. So if you look at example 1, 5 over the square root of 5, of course there's no simplifying to do whatsoever as far as the order of operations, other than now we know we cannot leave a radical in the denominator. So there's only one term down there, more specifically a square root. So the way we rationalize a radical, more specifically a square root, when there's only one term in the denominator, is we simply multiply the numerator and denominator by that radical, square root of 5 in this case. The numerator is just then 5 square root of 5. The denominator, square root of 5 times square root of 5, multiplying two radicals with the same index, gives us the square root of 25, which we notice is a perfect square. So that's how we get rid of that radical. It becomes 5. So we rationalize the denominator at this point, but of course we still have a fraction that we need to make sure is simplified, and we see the 5's cancel out, so all that simplifies to just the square root of 5. Example 2. We're still simplifying, so look inside the radical. We have a fraction, of course. In this case, the fraction does not reduce at all, so we've seen problems like this. We know how to simplify. We rewrite the numerator in its own radical, the denominator in its own radical, and simplify. The numerator, square root of 80, becomes 4 square root of 5. The denominator, we can't do anything with the 3, but the square root of n to the 10th becomes n to the 5th times the square root of 3. So at this point, we simplified as much as we can following the order of operations, but now we know we can never leave a radical in the denominator, which of course we have, so now we have to take it a step further in order to simplify and get rid of it. Now we still only have one term in the denominator, one term though made up of two factors. So what we're going to do, since we only have one term in the denominator, in order to rationalize it, get rid of it, you multiply the numerator and denominator by that radical. The numerator gives us 4 square root of 15. The denominator, you're going to notice when you're multiplying two identical square roots, it's going to simplify to just the radicand. So it would give us the square root of 9, and the square root of 9, of course, is 3. Or we would know that multiplying two identical square roots will simplify to just that radicand 3. Now, of course, we still already have that n to the 5th down there. So the rationalized denominator, 3n to the 5th. Take a quick check and see if you can reduce the remaining fraction. And we see that we cannot. This is our final simplified answer. And example 3. Notice we cannot simplify or reduce the fraction. Nothing to do with the numerator at all at this point, but the denominator, that radical, we can simplify a little bit. Not the 10, not the x, but that y cubed becomes y times 10xy. Still only one term in the denominator. So in order to rationalize that square root, we multiply the numerator and denominator by that square root, 10xy in this case. The numerator becomes 2x to the 8th square root of 10xy. The denominator, multiplying two identical square roots, gives us just that radicand, 10xy, times that y already down there, so 10xy squared. And now just simplify the remaining fraction. 2 over 10, of course, reduce, leaves us just a 5 in the denominator. X to the 8th over x leaves us x to the 7th in the numerator. Can't do anything with that radical, square root of 10xy, so it just carries through. Same thing as the y squared in the denominator. The next method for rationalize the denominator is if we have two terms in the denominator. Whether they're both square roots or maybe only one of the terms is square root, it doesn't matter. If there's two terms in the denominator, we're going to begin by, of course, simplifying anything we possibly can, reducing the radical. And then what we're going to do is we're going to multiply the numerator and denominator by something called the conjugate of the denominator. And then, of course, simplify the remaining fraction or rational. So example 1, we have a fraction, nothing reduces or cancels out, but we can simplify one of those radicals. That square root of 20 becomes 2 square root of 5. But that's about it. Now it's time to get rid of the radicals. Obviously, we have two terms in the denominator, so multiply by the conjugate of the denominator. The conjugate of the denominator is going to be 2 square root of 5 minus square root of 2. You just take the opposite sign, and of course whatever you do to the denominator, you have to do to the numerator. So the numerator, distribute that 10, gives us 20 square root of 5 minus 10 square root of 2. The denominator, multiplying two binomials, we need a FOIL. So the first term's 2 square root of 5, 2 square root of 5 gives us 4 square root of 25. The outer and inner terms, minus 2 square root of 10 plus 2 square root of 10, and the last term's minus square root of 4. So if we take a break and see what we've done so far, remember we're trying to get rid of the radicals in the denominator. We began with 2. At this point we have 4, so it looks like we're kind of moving backwards in the wrong direction until we start looking at them and simplifying. We notice the outer and inner terms cancel each other out, and the first and last terms are perfect squares. Square root of 25, of course, is 5, so 5 times 4 is 20. Square root of 4 is 2, so that entire denominator simplifies to 18. So we've rationalized the denominator. Just take a quick check and see if we can reduce the fraction. We have two terms in the numerator, one term in the denominator, and they're all divisible by 2. So it becomes 10 square root of 5 minus 5 square root of 2 all over 9. And one more, example 2. Square root of 5 plus square root of 2 divided by square root of 10 minus the square root of 2. So we can't simplify at all as far as the order of operations. So all we need to do in order to simplify is get rid of the radicals in the denominator. Once again, we have two terms down there, so we know we multiply by the conjugate of the denominator. Square root of 10 plus the square root of 2. Just take the opposite sign. So multiply the numerator and denominator by the conjugate. And since there's also two terms in the numerator, we see we're going to have to FOIL twice. FOIL the numerator and FOIL the denominator. So beginning with the numerator, the first terms becomes square root of 50. The outer terms plus square root of 10. The inner terms plus square root of 20. And the last terms plus square root of 4. The denominator. The first term, square root of 100. The outer and inner terms. What you're going to notice here, that's an important property of multiplying by the conjugate, the outer and inner terms will always cancel each other out. So really you don't even have to multiply them, but you certainly can if you want. Square root of 20 minus the square root of 20, and then the last term minus square root of 4. So simplify, going back to the numerator, the square root of 50 becomes 5 square root of 2. The square root of 10 does not simplify. The square root of 20, 2 square root of 5, and of course the square root of 4 is just 2. All over the denominator, outer and inner terms cancel out. Square root of 100 is 10, square root of 4 is 2, so 10 minus 2 becomes 8. So we've rationalized the denominator. Just take a quick check and see if we can simplify the remaining radical. Keep it in mind that in order to cancel or cross anything out, every single term within the numerator denominator must have that common factor. So nothing to cancel out, nothing to simplify. This would be our final simplified answer.